So here it says suppose that a mass is hanging from a string that's attached to the ceiling. It is being swung in a circular motion. It says that the mass is swinging at a constant speed of 5 meters per second, and then the mass is located 5 meters away from the center of the circular motion. What is the angle theta of the hanging mass from the ceiling? All right, so here we have this diagram that's provided for us. The angle that it wants is this angle that touches the ceiling, which is touching the horizontal axis, and then the diagram shows that it's revolving at a constant speed of 5 meters per second. So I do want to point out, even though the diagram here says v, v here is not velocity, because your velocity constantly changes direction. V here stands for speed, and the speed here is a constant 5 meters per second. So if you can just visualize maybe something or someone running around around a track at a constant speed, okay, not velocity, because the direction changes all the time. All right, and the radius of this circular orbit is 5 meters as drawn and as stated in the problem. All right, so let's crack this out. One, I want to go ahead and draw my forces first, and then I'll set up the physics, okay? So here's my force of tension from the bob or the mass pointing to the ceiling, which is holding it. And then here's my tension, and because my tension is a diagonal, in this case it's going to point, see, northwest. It has to have components. So here's my tx. My tx here is going to point left because the vector itself is going to go left and up. And then ty is going to point upward. So make sure you draw your components correctly. And then I understand that the theta given is touching the ceiling. However, because this is my right triangle, I'm going to go ahead and move theta down here as well. Okay. So this theta that's given is the same as this theta that touches the x-axis down here, or that touches tx and the hypotenuse of which is t. And then f of g, hopefully by now in this course, you know how to draw f of g just pointing down the page. Okay. And then I do want to point out that ty, why I drew it over here, I'll put this animation back. Why I drew it over here, this is just to make it a right triangle. So one, you can do your cosine. So tx here would be cosine because the angle given touches the x-axis. And then ty here is your opposite, which is going to be sine. Okay, so, but you can definitely move your ty over here if it helps. Okay, some folks draw ty over here because it makes sense, because if you compare f of g and ty, these two things have to equal because the mass is revolving in a circular plane, which suggests that it's not oscillating up or down. So it's just moving in a flat horizontal plane, okay, which implies ty must equal to f of g for this condition or phenomenon to occur. All right, so keep that in mind. Again, you can leave it over here. I like it over here because to me it's not that difficult to go, wait, there's an arrow up and there's an arrow pointing down in the y direction. But some folks like to draw it where it, kind of touches on the same axis because it helps them visualize and they don't miss anything. All right, so, but that's up to you. All right, let's go ahead and crack it out. Keep in mind that we are trying to find the angle after all. So I'm going to set up my x and y information here. So in this particular problem, my f of c will be contributed to or by tx, because tx is the force component that is pointing towards the center circular motion, okay? I'm just going to expand f of c down to mv squared over r, and then tx here. I need to introduce theta because ultimately I need to find theta. So I know that tx, though, based on this angle that's given to me, so theta touches the horizontal axis, which is the ceiling, which is the same as the one down here. So tx is cosine because this is cosine. Why? Because it's the adjacent leg to this angle. Okay, so make sure you do sine and cosine correctly. So for this particular problem, angle given touches the x-axis, so x is cosine, y is sine, just like normal. All right. So here, I'm going to go ahead and multiply both sides by r, divide both sides by m to get v squared by itself. And then here, I don't know what t is. Okay, so if you've seen the other few videos, you're left with unknowns. All you have to do is kind of chuck your way through. Well, I need to keep cosine. I know what r is. R is 5. I don't know what the mass is because mass wasn't given to me. But what I don't know is I don't know t either. Yeah, I know v is 5. So the only thing here that's keeping me from finishing this problem is the t. Okay, but I don't know what t is. What I can do though is set up the information in the y direction. As I stated earlier, ty for this particular problem must equal to f of g because the mass is tracing out a horizontal plane that's parallel to the floor. And then I can break up ty into t sine theta. So this is where if your sine and cosine are off, you're going to get some jacked up answer. So make sure you pay attention to cosine and sine before you attack these types of problems, okay? So here I highlighted t just to keep you focused. Ultimately on the left side, we know v is 5. We know r is 5. We don't know what m is. And then we don't know what t is. But we can solve for t, right? We can get rid of t. So on the right side, to get rid of t, I can go ahead and solve for t by dividing both sides by sine theta. So here f of g is simply mg, and then if you were to divide both sides by sine theta, you get mg over sine theta. Well, now that we have a statement for t, we can substitute in on the left side. So I just did a quick substitution here. So instead of t, I did mg over sine theta times cosine times r divided by m. So I do want to point out here that you have a fraction multiplied by this quantity on the right, and then you're dividing it by m. So I'm just going to clean up a little bit. So here I'm just going to take mg times it by cosine r. So everything goes on top there. The sine theta on the bottom here is by itself because cosine theta and r doesn't have a denominator, so that's just a 1. So it'd be sine theta times 1, which is just sine theta. And all of this sits over m, which I just carried over. So here you have a fraction on top divided by m, right? So if you have a fraction divided by m, you would simply multiply the two denominators. So it would just be m times sine theta, which is now your new denominator. So that's what I did down here. I just did m times sine theta. And then you notice m on top and bottom will cancel out. So as you can see here, why the mass wasn't given, you don't really need it because it cancels out in these functions. So the speed of an object is independent of its mass. Okay, it all depends on the angle, like how fast you're twirling it. All right. So here, I'm going to do a couple steps for you just to save some room on the screen. Here, I need to solve for theta. So don't forget, the goal is to find this theta, right? So at this point, you can do cosine over sine, but what I like to do is I like tangent. So watch my cursor. The sine theta, I want to multiply both sides or move it to the top left. At the same time, though, I want to move cosine of theta from the top right to the bottom left. That's why this left side looks like this. Okay, so I move sine up to the left. I move cosine down to the left. And then at the same time, though, I need to get rid of this v squared. So I'm going to divide both sides by v squared. So really, I'm circling the v squared term here, and I'm just going to move it to the bottom right. So it's just a little quick switcheroo here. So the only thing left in the top numerator is g and r because I already moved cosine. And then now the new denominator is v squared because I moved it down. I like to do this because sine over cosine is just tangent. Okay. Again, you don't have to. You can use cosine over sine, which is cotan. But I like tan, so I'll do that move just so I have tan. And then here we have tan is equal to g r divided by v squared. Well, we pretty much know everything, right? We know g is 9.8. We know r is 5. We know v is 5. So to get theta, just inverse tan or divide both sides by tan, which makes it inverse tan. So make sure you use parentheses here. So you notice here my work is tan inverse gr divided by v squared. So I'm just going to plug in values. G is 9.8, r is 5, and then v here is given in the diagram as 5. I'm going to square that because it's squared. And then if you punch in your calculator correctly, hopefully in degree mode, you should get about 62.9 degrees. And that is your answer for this one. All right. I hope that helps. Stay nerdy. Don't be whack.